Matt and Dan recently performed a tyre width test on the Cobbles of Flanders, and they did so in order to try and show just how much faster a wider tyre would be on rough roads. Except the results weren't quite what you might have expected, and we went into a little bit more detail as to why that was the case in our previous Geek Edition video, which there is a link to on screen now. Fundamentally though, the reason why the tyres weren't faster in this case was because Dan and Matt kept the tyre pressures the same for all the widths of those tyres, thus negating any effect of suspension. So, undeterred, they went back to see whether or not changing tyre pressures would therefore lead to significant results and make Matt and Dan faster and more comfortable over rough roads. They went back to the rough and brutal pavé of northern France. Now let's have a quick run through of the testing conditions first. Matt and Dan chose a section of the 5-star Carrefour de l'Arbre cobbles for their test. Now these are some of the toughest cobbles in all of Paris-Roubaix, and they're often where the winning move goes. Now they rode the section 3 times at a set effort level, though it was different between the two of them. And they used a set of 28mm Continental GP 4000s. They dropped the pressure for each run. They started at 100 psi, so 6.9 bar, then 70 psi, 4.8 bar, and then finally 45 psi, just 3.1 bar. Each run was timed, but then they also used Dan's exceedingly high-tech vibration meter, an open water bottle filled with water, and whichever run left the most water in the bottle would be the comfiest tyre pressure. It probably surprised only Dan that if you do ride with an open water bottle across some of the toughest cobbles in professional cycling, then no matter what your tyre pressure, there wouldn't be much water left in it at the end. But the other results are on screen now, and as you can see, both Matt and Dan were significantly faster each time they dropped their tyre pressure, which is a relief because that was what we were expecting to see. But why were we expecting to see that? And is it of any relevance to you and your riding? First, let's talk rolling resistance, shall we? We touched on that in the previous video. One of the main causes of rolling resistance for a rubber tyre is hysteresis, or more specifically, elastic hysteresis. Now this is a property of a deformable material whereby the energy of deformation is greater than the energy of recovery. So basically, what that means is that actually the energy required to deform the tyre in the first place is got to be greater than the energy you get when the tyre bounces back. So if you think of it in terms of a ball, for example, you drop it from a height, it is never going to bounce quite back up to the height that you dropped it from. The energy will go in the form of heat or possibly a little bit of noise as well. Now, tyre hysteresis is more pronounced when the tyre has to deform more, so on bumpy roads, or when the pressure is less, and so the tyre is literally deforming more in your hands. So you would think, therefore, that in order to reduce hysteretic loss, you need to whack a load more pressure in your tyre, and therefore you would go faster. And you know what? For many years, that was the conventional wisdom. You want to go fast, you stick a load of pressure in your tyre. And actually, on super smooth roads, and like a velodrome, for example, that is absolutely the case. However, on anything less than a super smooth road, and in fact of increasing significance the rougher the road gets, you have another thing at play: suspension loss. When you ride your bike down any stretch of road, your body is going to be vibrating slightly. And the worse the section of road, the more it will vibrate. As we can see here, with Dan vibrating quite significantly as he rides his bike across the pavé. And his skin, his tendons, muscles, bone will all be rubbing against one another, and that will be generating friction. Friction, which therefore turns to heat, which is energy lost. And actually the amount of energy that can be lost is really quite significant. So according to Bicycle Quarterly, there was a study carried out in 1986 by the US Army to try and find out which seats they should use in their tanks. And in doing that research, they discovered that a tank driver may have to absorb up to 2,000 watts. 2,000 watts. Yeah, so no section of pavé is ever going to be quite that bad, but it does illustrate the point. So the worse the vibrations get in your body, the more power that you will need to overcome them, and the more power, therefore, that you need to put out in order to keep moving forwards down the road. So, to combat those vibrations, you let a bit of pressure down in your tyres, and you can actually feel this just out on your local roads. You don't need a section of pavé. Whack 120 psi in, ride down a rough road, and then let 40 psi out and do it again. You will notice the difference. There is a problem though, isn't there? Because at what point does hysteretic loss exceed suspension loss? Well, to find out exactly is actually quite difficult. And to be fair, how much pressure is the optimal pressure will vary depending on the exact road surface that you're riding on. Although you don't need a power meter, you can do it on feel. Basically, if you start letting a little bit of tyre pressure out, you can feel the vibrations reducing each time you ride across that section of road, up to a point where the bike then starts feeling sluggish. So that should be the point at which hysteretic loss exceeds suspension loss. Either that, or you get to a point where you bottom the tyre out all the time and you get a pinch flat. Which brings us neatly on to the reason why wider tyres perhaps should have been faster over the cobbles in the first place. The wider the tyre, the more force is needed in order to actually bottom it out. So that's the point at which your rim strikes the road and you may well end up with a pinch flat. Now, that isn't actually due to the width of the tyre at all, it's due to the increased height of the tyre that a wider tyre will actually give you. And why does that matter? Well, it means that you can therefore run lower pressures, get the benefit of reducing those suspension losses with less chance of that rim striking the tarmac and you getting punctures. Now, unfortunately, despite being armed with all of that knowledge, there is no universal panacea for tyre width and tyre pressure. It is completely dependent on your body weight and the types of roads that you ride. Hence the kind of guidelines about running 25 width tyres on smooth roads and 28 and 30mm wider tyres on bumpy roads. Or in fact, as we found out last year, if you ride over cobbles, you probably just want to ride a mountain bike. Oh yeah. If you want to see that little experiment we did, in fact, you can get through to it just down there. Please do also make sure you give this video a thumbs up. And if you haven't seen Matt and Dan's experiment about tyre pressures, you probably want to watch that right now. And that one is just down there. Geek out.